about ionic bonding, right? So I am just taking an example of sodium and chlorine, which will form an ionic bond, right? So if you see the sodium and chlorine, the sodium has a tendency to give away one electron, and chlorine has the tendency to gain that one electron since it has only 7 outer orbit electrons. So once it gains the next one, that will achieve the 8th electron. So that will be stable, right? So sodium and chlorine, in order to gain the stable energy state, they are transferring electrons in between them, right? So while transfer, sodium loses its one electron and chlorine gain that particular electron, right? So now due to this, there will be an attraction between them, right? There will be an attraction between these two, right? Since it is giving and it is gaining, there will be an attraction. At the same time, sodium has already 10 electrons in the inner orbitals. So the first two, they won't have any problem, but the other one would be the last orbit. So now the sodium and chlorine, they does have some last orbit electrons. So that's what I'm showing here, right? Sodium also will have 8 outer shell orbit, and chlorine will also have 8 outer shell electrons. So these electrons, they will try to repulse these two, right? Due to this electron, when they are coming closer, the already available electrons, they will try to repulse. So here we have the attraction energy, and here we have the repulsion energy, right? So once this attraction and repulsion and everything is over, we will have this net energy. So that is a total energy. So what I have shown in this blue dot line here is the attractive energy, right? So attractive energy can be denoted by EA. Okay. Similar way, what is shown in this green dotted line is the repulsive energy, right? Repulsive energy. So that is this ER, right? Sum of these two, the attractive energy and the repulsive energy, will be the final energy En. So net energy would be the sum of EA and ER, that is attractive and repulsive energy, right? Now this attractive energy can be written as minus A upon R. So this is a standard formula, right? Minus A upon R. Similarly, this repulsive energy can be written as minus B upon R to the power n, right? And this A and this B are constant numbers, while this R is the interatomic separation, right? So interatomic separation means the distance between the atoms of those two elements which are now being bonded, right? So now our case is sodium and chlorine. So sodium and chlorine. So if I consider this is the atom of sodium and this is the atom of chlorine, the distance between these two atoms is the R, right? So that is this R, interatomic separation R. So I am drawing a graph between R and energy E, right? Energy E. So repulsion energy I will take positive and attraction energy I will take negative, right? You can take in the otherwise also, right? Usually we take like this, right? So then we'll draw a graph. So attraction energy graph is minus A upon R, right? Minus A upon R. So there, if you draw this blue dotted line is the graph, right? So it will go like this, right? And here, if you see the repulsive energy, equation is minus B upon R to the power n, right? So if you draw that graph, it will go like this, right? So this B upon n graph is more closer than this one to the x-axis because it is to the power, right? So if you want to check, you just can take your copy and you can write, just you put arbitrary numbers, right? So A and B, you keep it constant, right? And for R, you put like 0.1, 0.2, 0.3, 0.4 and observe what will happen to the equation, right? Since it is R to the power n, this is too closer to the x-axis than this one, right? So the net would be on the attractive side, right? Net will be on the attractive side. In this particular graph, there is a certain energy level where the energy is minimum, right? The energy is minimum, which we call it as E naught, right? This is the balance energy of this minimal state while these two forming the bond, right? In order to achieve this level, they form the bond, right? So there are a few examples for ionic bonding, right? So I told you usually those at this end and those at this end will form the bond, right? Usually, right? So in the left hand side, you see we have sodium, potassium, rubidium, cesium, francium. In a similar way, magnesium, calcium, strontium, barium, and radium. So these all will lose 2 electrons since they are in the second block, and these, second column, and these all will lose 1 electron. In the similar way, these at the 7th column will acquire 1 electron, and these at the 6th one, they will acquire 2 electrons, right? While this one, they does not have any reactions at all, right? So here give up electrons this way, and here this way acquire electrons. So this is how the ionic bonds are formed, right? So there are a few examples. NaCl. So on this side we have Na, which have 1 electron, and this side I have Cl, right? Cl, which also need 1 electron, so they will form NaCl, right? And there you see Mg, which will lose 2 electrons, and O, which will gain 2 electrons, so that will form MgO, right? And here we have calcium, which will lose 2 electrons. Yeah, so in that case, so calcium 2 plus, so which will lose 2 electrons. But this fluorine, right? Fluorine is over here, that will gain only 1 electron, right? F minus, right? So it has given 2 electrons, but this F can't take those 2 electrons. So what will it do? It will call another F, right? And now these 2 fluorine will give the gain this electron. So 1 electron will be given for this F, and 1 electron will be given for this F, right? So here we have 1 calcium and 2 fluorine. So we will write it as CaF2, right? 1 calcium and 2 fluorine. In a similar way, if I write for K and O, right? K and O. So potassium, you see, it will lose 1 electron, right? So 1 plus. O will gain 2 electrons, right? So this potassium is not enough to supply enough electron for this O, right? Because it can supply only 1 electron. So what will happen? Another potassium will come to supply the other electron to this O. So now we have 2 potassium, so K2 and 1 oxygen, right? So this is how the ionic bonds are formed, right? So if it is losing 1 electron and gaining 1 electron, that's fine. NaCl. Losing 2 electron, gaining 2 electron, that is fine. MgO. The CaF2, it is losing 2 electron, but F can gain only 1 electron, so it will call for another F. So those 2 electrons will be given, one for this one and one for that one. So now CaF2. Like that, K will also K2O. K can supply only 1 electron, but O can supply. O can gain 2 electrons. So now it is K2O, right? 2K for 1O, right? So this K will supply 1 electron for this O, and this K will supply 1 electron for this O. So 2K is supplying electron for this O. So that is K2O, right? So 2K and 1O.